Bismillahirrahmanirrahim. Assalamu alaikum. In our today's lecture, we'll be covering two methods. One of them is the LU-Decomposition method, and the second one is the CROUT'S method. What are these methods? As usual, first of all, we'll be describing the theory of the methods, and then we shall be applying them in order to solve a question. So let's take start the procedure behind the LU-Decomposition method. The title of the method is LU-Decomposition method. The other name of this method is the triangular decomposition method, and one more name you can find in literature as the factorization method. So these are the different titles given to this method. But the most common name to this method is the LU-Decomposition method. The procedure starts with a system of linear equations. Suppose we have a set of linear equations, say a11x1, a12x2, a13x3 is equals to b1, a21x1, a22x2, a23x3 is equals to b2, and then a31x1, a32x2, a33x3 and b3. So suppose we have a system of three linear equations with three unknown. From here we can transpose this system into the matrix form as a11, a12, a13, a21, 22, a23, 31, 32 and 33. Along with the column vector of the unknown x1, x2 and x3, and on the right side we have the constants in the form of b1, b2 and b3. So here we have transformed the system into the matrix form. The first matrix is known as the coefficient matrix, and the other one is the unknown column vector, and this is the right side of the system. Generally, we show this coefficient matrix by the letter A, and the unknown are generally represented by the letter X, and the right side is generally represented by the letter B, in the form of AX is equals to B. Let us call this as your first equation. These subscripts are representing the corresponding positions of the elements in the matrix. And now from here the procedure starts. Here we assume that we can decompose A into the product of the two matrices. One of them is L and the other one is U. What is L here? L is the unit lower triangular matrix. And what is U? U is a simple upper triangular matrix. So let's write down here So here we have decomposed A into the form of L and U, where L is a unit lower triangular matrix, and the order of L and U is the same as that of your matrix A. So it is 1, 0, 0, L21, 1, 0, L31, L32 and 1. This is your matrix L, and parallel to it we have the upper triangular form of U, U11, U12, U13, 0, U22, U23, 0, 0 and U33. Okay. So we can decompose A into the product of the two matrices of L and U, where L is a unit lower and U is the upper triangle form. And on bringing this into the equation number 1, we get, by using equation 2, equation 1 gives A will be replaced by L and U, and X is always there, and the net result is equals to B. Let us call this as your equation number 3. Here we make a substitution here by taking Ux is equals to, say, Y. And what is Y here? Y is a column vector containing as many unknown as these are involved into your system of equations. So here we have taken 3 unknown due to the reason we have 3 unknown involved in our system of equations. And from here, whenever we substitute this into the equation number 3, so this takes the form Ly is equals to B. So this is the last step you have to do. If you look at on all these steps involved, first of all, you have to decompose A into the product of the two matrices which are L and U, and then we go through this process and reach to this level. From here we will be taking start. From this equation we can find Y, and then after finding Y we can substitute this Y here and solving this equation for the unknown X. So from here we can find the unknown in the form of X1, X2 and X3. So this is the brief description of the whole procedure, but definitely it is a bit confusing how actually we are getting all these things. The first question is, can we decompose all A's into L and U? This is an important question. And second, from where L and U, or how we can obtain L and U? Because these are all unknown quantities. If you look at these two matrices, these contain collectively 9 unknown entries. So in order to obtain these 9 entries, what we have to do, so this is an important thing to understand. First question, can we decompose all A's into L and U? Definitely not. We can decompose only those A's in which the minors of all the elements of A are non-singular. This is important. And second, how we can find the L and U? So let's describe to determine the values of L and U. So here we take start. The product of L and U should be equals to A. This is the equation from where we can find L and U. We already know that L is a unit lower triangular matrix, 1 0 0, L2 1 1 0, L3 1, L3 2 and 1. And along with it we have the unknown of the U upper triangular matrix 1 2, 1 3, 0, U2 2, U2 3, 0 0 and U3 3. And the right side is A. If you remember, we have shown it by A1 1 1 2, 1 3, 2 1 2 2 and 2 3, 3 1 3 2 and 3 3. Okay. Now we have two matrices on the left side, and the product of these two should be equal to this one. Now if we take the product of these two, what do we get? Row number 1 with the column number 1 will give you U11. Similarly, row 2 with column number 1 gives you L21, U11. Row number 3 with column number 1 gives you L31, U11. Okay. Similarly, if we take the product of the other elements, it gives you U12 here, and it will be L21, U12 plus U22 and L31, U12 and L32 and U22. Okay. And similarly, you can fill these three of yourself. It's not very complicated. I'll do it a bit later whenever I'm going to solve the question. So there, inshallah, I'll be writing all these entries there. This is just to express how actually we can calculate all these unknown 9 involved in these two matrices. So on the right side we have A1 to A1 3 and 3 1 3 2 and 3 3. Okay. Now if you make the comparison of these two, the first element on this side should be equals to the first element on this side. So we can get the first unknown A11. And similarly, the second gives you U12 is equals to A12. And here it will be, of course, U13. If you multiply this row with this one, so this will be U13. So here we can get U13 is equals to A13. So through this way, we can calculate all the other elements. We got the first three elements by making the comparison of these corresponding entries to the right side matrix. Similarly, if I take this entry, L21, U11, this will be equivalent to this A21. From here, you already know the value of U11, which is A11. I can substitute it here and transforming it to the right side, this gives you L21 is equals to A21 over A11. So we got one more unknown. And on the same pattern, if you proceed on the same lines, so you will be able to find all these unknown of yourself. So this is the way through which we can obtain LNU. This is the bit lengthier process through which we can obtain all these L as well as of U, and then after that the procedure is very simple. So I'll describe all these steps once again through an example. Let's start solving the question. Okay, the question is you are given a system of linear equations and you are required to solve it by using the LU-Decomposition method. The question is 4x1 plus 5x2 minus 2x3 is equals to 5.6, 2x1 plus 3x2 plus x3 is equals to 1.3, 2x1, 4x2 and plus 4x3 is equals to 9.5. So this is the system which we are going to solve by using the LU-Decomposition method. Whenever we transform it into the matrix form, the coefficient matrix will be 4, 5, minus 2, 2, 3, 1, 2, 4 and 4. This is your coefficient matrix. The column vector of unknown containing three elements x1, x2 and x3, and on the right side we have B containing elements 5.6, 1.3 and 9.5. After that we have to decompose A into the LU form in the product of L and U. So here we have now, we shall be taking start from the equation LU is equals to A, where L is, we already know it's a unit load triangular form. So here we write down L21, 1, 0, L31, 3, 2, 1, and U is an upper triangle. U11, U12, U13, and here 0, U22, U23, 0, 0 and U33. And on the right side we have the coefficient matrix A, which is 4, 5, minus 2, 2, 3, 1 and 2, 4, 4. Now we take the product of these two. We have already done this step, but here we have to actually solving and finding out all the unknown involved in ln u. So here when we multiply, we get the first row from here and first column from here, we get u11. Second row with the first column gives you L21, U11. Third row with the first column gives you L31, U11. So these are the three entries for column number 1. First row, column number 2, it gives you U12. Second row, column number 2, L21, U12 and U22. Third row, L31, column number 2, U21, U12 plus L32 and U22. So we got the 3 more entries for column number 2. One more column is there. Row 1 with column 3 gives you U13. Row 2 with column 3, it gives you L21, U13 plus U23. And the third one is L31, U13 plus L32, U23, and one more entry will be there, U33. So this is the output after taking the product of these two matrices. And on the right side, we have the coefficient matrix A containing elements 4, 5, minus 2, 2, 3, 1, and 2, 4, 4. So this is the so far situation we got. Now we are going to make the comparison of these two matrices to obtain all the unknown. Okay, you have to keep all these things in your knowledge and then we can use it once again. Okay. Now, if you compare these results, this is 1, 3. From here, the first entry, which is U11, that gives you, on comparison with this quantity, gives you U11 is equals to 4. So we got one first unknown out of 9, because ln u collectively contains 9 unknown. Similarly, U12 on this side, it is equals to 5. This is your second unknown. Comparing U13 with this gives you minus 2. So we got first 3 unknown very simply or easily. Now we come to this entry. L21 U11 is equals to 2 from here. And substituting the value of U11 here, which is 4, and shifting it to right side will give you L21 is equals to 1 by 2. So we got one more unknown. Now we go to this entry L31 U11, that is equals to, according to the correspondence, it is equals to 2. From here on, substituting once again here the value of u from here and transforming it to the right side will give you L31 is equals to 1 by 2. Okay. So we got 5 out of 9. Now we go to the next entry, this one, L21 U12 plus U22, and this quantity will be equals to 3. Okay. Now here we have L21. L21 is 1 by 2. U12 is here 5 and plus U22, which is equals to 3. On transferring the left side's constant, this constant can be shifted to the right side, and taking the difference will give you U22 is equals to 1 by 2. Now we go to the next entry, L21 U13 plus U23 is equals to this one, which is equals to 1. Now putting in the values, L21 is 1 by 2, U13 is minus 2, and we can calculate U23. And and the net result is equals to 1. And from here on simplifying, this will giving, from here we get -1 and then it gives you +2. Okay, so far we obtained 5 plus 2, 7 entries. Now we have 2 more entries to measure. So here we used L31 U12 plus, I'm using this quantity, plus L32 U22, and this will be equals to +4. On putting in the values, L31 is 1 by 2 from here. U12 is 5 plus L32 you have to calculate, and U22 we have already calculated, which is 1 by 2. So from here we can calculate L32 and the net result is equals to 4. Okay, and now you can simplify it and the result is going to be equals to 3. Okay, you can verify it very easily. And the last entity is this one. We are using it L31 U13 L32 U23 plus U33, and the net result is equals to 4. And from here we substitute the corresponding values. L31 is 1 by 2, U13 is -2 plus L32 is 3, U23 is 2, we can calculate U33, and the net result is equals to 4. On simplifying, we'll be having U33 is equals to -1. Okay, so here you can see ultimately we succeed in finding all the 9 unknown for LNU. So after this, now we can rewrite LNU by putting all these values of LNU is so far obtained. So let's erase from here. So the matrix L will be now equals to, we obtain the entries and substitute them back into L and U, can give you 1, 0, 0. L21 is 1 by 2 from here, then 1, 0. L31 is 1 by 2, L32 is 3, and it is 1 here. So this is your L. And now we write down U11. U11 is 4, U12 is 5, and then -2. 0, U22 is 1 by 2, U23 is 2, 0, 0, and U33 is -1. So these are the 2 matrices of L and U. I hope you can understand it very easily and you can verify all these calculations of yourself. Now we proceed to the next step of the algorithm. So this is the major step of this whole method. After calculations of L and U, the next step is to calculate Y. Now we use the identity algorithm step. Ly is equals to B, where you have to mention here what is Y. Y is a column vector containing as many elements as there are unknown into your system of equations. So here we write down L. L is here 1, 0, 0, 1 by 2, 1, 0, 1 by 2, 3, and 1. Along with it, the column vector of unknown y1, y2, and y3. And on the right side, the values of B. And the value of B were 5.6, 1.3, and 9.5. Okay. Now, if you transform back into the equations form, so from the first we get y1 is equals to 5.6. So we got one more unknown. From the second we get 1 by 2 y1 plus y2 is equals to 1.3. Now we can use the forward substitution. This y1 can be used here. So from here we get 1 by 2 into 5.6 plus y2 is equals to 1.3. Okay. Now simplifying and transferring the constants to the other side will give you y2 is equals to minus 1.5. Okay. And similarly from the third equation we get 1 by 2 y1 plus 3y2 plus y3 is equals to 9.5. And we have y1 as well as y2, so we can put them here to calculate y3. So 1 by 2 times y1, which is 5.6, plus 3 times y2, which is minus 1.5, and plus y3. And right side is equals to 9.5. And from here, if you simplify for y3, the net result is equals to 11.2. Okay. Now we succeed in finding the y. So here we can write down y is therefore equals to y1, which is 5.6, y2 is minus 1.5, and y3 is 11.2. So these are the three more unknown we calculated. So now we are at the last step of your algorithm, where we are able to find out the unknown, actually unknown x1, 2 and 3. There we have to use this matrix. So you have to keep this matrix in your mind. I'll be reading it and solving all over here. Okay. Now we take start from the equation. If you remember, u times x is equals to y. We have u, we substitute it here, 4, 5, minus 2, 0, 1 by 2, and 2, 0, 0, and minus 1, along with the column vector of unknown x1, x2, and x3. And on the right side we have y, and we have just calculated it, 5.6, 1.5, and 11.2. Okay. Now transform them into the equations form. Whenever you transform it into the equations form, it gives you 4x1, 5x2, 2x3 is equals to 5.6. Second equation gives you 1 by 2 x2 plus 2 times x3 is equals to 1.5, and minus x3 is equals to 11.2. Now by using the backward substitution we can obtain all these three unknown. From the last equation we get x3 is equals to 11.2 with the negative sign, and putting this value here into the equation number 2, you can call it 2, x2 plus 2 times x3 is equals to minus 1.5, 1 by 2 x2 plus 2 times x3 is minus 11.2, okay, in place here, and this is equals to minus 1.5. On shifting all these constants on the right side, you can get the second unknown, and this is going to be equals to 41.8. And now after finding these two, we can use the first equation to obtain the last unknown, 4x1 plus 5x2 minus 2x3 is equals to 5.6. Okay, we have to calculate x1 plus 5x2, x2 is 41.8, and minus 2 times x3, which is 11.2, and net result is equals to 5.6. On simplifying, we'll get x1, and this is going to be equals to minus 56.5. So ultimately, we got the solution for the given system of equations. So x will be now equals to x1, which is 56.5, x2 is 41.8, and the last one is 11.2. So this is going to be your ultimate solution. Now you can verify this solution by substituting it back into the equations one by one, and if this solution satisfies all the equations involved in the system, then this is going to be the correct solution. Else, of course, it is not. Okay, now after doing this LU decomposition, now we move towards the next method, which is the CROUT'S method. And CROUT'S method is actually the twin of the LU decomposition method. That's why I'm linking these two methods in the single lecture. So here I describe the procedure for the CROUT'S method. There will be a very minor difference. So let's see what it is. Okay, now we talked about the CROUT'S method. The CROUT'S method once again starts from the same system of equations Ax equals to b, as we have done in the previous case of LU. And then you can decompose A into the product of L and U once again. And this time L and U are not the same as that you have defined in the previous case of LU decomposition. So here L is not unit lower triangular. It is simple triangular, lower triangular matrix L21, L22, 0, L31, L32, and L33. And U is an unit upper triangular matrix. So here this will be 1, U12, U13, 0, 1, U23, 0, 0, and 1. So this is the difference in between the CROUT'S and the LU decomposition. In LU decomposition, we have taken L as a unit lower and U as an upper triangular. Here we are taking L as a simple lower and U as a unit upper. And remaining steps are same. Whenever we put it here, it gives you LU x is equals to b. On making the substitution of ux equals to y, where y is a column vector containing as many elements as these are involved into your system of equations. So here we are working for a 3 system equation. So we take y1, y2, and y3. And on substituting here, it gives you ly is equals to b, and from here we can calculate y as you have seen in the example, and then put this value of y here, you can obtain the ultimate x, which is the required solution of the system. Now, after knowing the algorithm for the CROUT'S method, now we apply it on an example. The example is slightly different from the previous one. So here we start solving the example containing 3 equations. The equations are 2x plus y plus 4z is equals to 12, 8x minus 3y plus 2z is equals to 20, and 4x plus 11y minus z is equals to 33. Okay, the first step is you have to defining the coefficient matrix, which is 2, 1, 4, 8, minus 3, 2, 4, 11, and minus 1, and the unknown are x, y, and z, and the right side containing the constants are 12, 20, and 33. So this is the so far situation, and now we have to start the algorithm. The algorithm starts from finding L and U. So here we define L and U is equals to A, where L is, we already defined the simple lower triangular, L21, L22, L2, this will be 0 here, L31, L32, and L33. And along with it, the unit upper triangular, U12, U13, 0, 1, U23, 0, 0, and 1. Okay. And on the right side, we have A, which is 2, 1, 4, 8, minus 3, and 2, 4, 11, and minus 1. Okay. So this is the so far situation here, and now we are looking for all these six unknowns in these two matrices. So we proceed on the same pattern. First we take the product of these two. First row with first column gives you L11, second row with first column L21, and similarly third row with first column gives you L31. L11, first row with second column gives you L11, U12, second row with second column L21, U12 plus L22, third row with second column gives you L31, U12 plus L32 and U2. So these are the entries for the first two columns. Now we take the first row with third column gives you U13, L11, U13. Second row with third column gives you L21, U13 plus L22, U23. And the third one is L31. I have taken the L31 with U13 plus L32, U23, and then L33, one more. So this is the product of these two matrices. So let's check it again. We have multiplied here. This is slightly, it is not looking correct. It should not be here. Okay. Third row with the second column, L31, U12, L32 over here, and I think remaining is okay. Okay, on the right side, don't forget to write down the coefficient matrix 2, 1, 4, or 8, minus 3, 2, 4, 11, and minus 1. Okay. Now we make the comparison of these two matrices to obtain the unknown involved. So we have to create a space here. Okay. The on comparison, the first entry L11 is equals to 2. Similarly, L21 is equals to 8. And L31 is equals to 4. We got first three unknown. And next is to find out the next entry from here. L11, U12 will be equals to 1. We have this value of L11, we can substitute it here, and shifting it to the right side gives you U12 is equals to 1 by 2. And similarly, we can use this entry L11 and U13, and this is equals to 4. From here, we have L11 is equals to 2, and then shifting it to the right gives you U13 is equals to plus 2. So we got 5 out of 9. Let me place them in the box so that we can see it properly. These are the unknown so far we have determined. Okay. After doing this, the next step is to find few more entries now I'm going to use this entry of the matrix L21 U13 plus L22 L22. So from here we first calculate. Basically we have used this one, this and this. Now we are using this one. L21 is 8, U12 is 1 by 2, and L22 you have to calculate. Okay, that's fine. So the right side will be equals to, according to this entry, is equals to -3. From here we get L22. So L22 is equals to -7. Okay. Now we use this entry L31 U12 plus L32, and the net result is equals to 11. From here L31 is 4, U12 is 1 by 2 plus L32 you have to calculate. On transferring all these on the right will give you L32 is going to be equals to 9. Okay, and we are able to find out how many 1, 2, 3, 4, 5, 6, 7. 2 more entries we are looking for, and from these two we can obtain these 2 entries. L21 U13 plus L22 and U23, and this is going to be equals to 2. From here L21 is 8, U13 is 2 plus L22 -7, and U23 you can calculate. So from here we can separate U23, and U23 will be equals to 2 after simplification. Now we use the last entry L31 U13 L32 U23 plus L33, and the net result is equals to -1. Okay. Now we put in the values. L31 is where is L31? L31 is over here. This gives you 4. U13 is 2 plus L32 is 9. U23 is 2, and L33 will be equals to -1 from here, and separate L33 will be equals to -27. So we ultimately succeed in finding all the 9 unknown involved in the 2 matrices of L and U. Okay, now we write all these entries so far we obtained in the form of L and U. L is 2, 0, 0, 8, -7, 0, 4, 9, and -27. From here we have written down this one. Similarly, the matrix U is 1, 1 by 2, and 2, 0, 1, 2, and 0, 0, and 1. After finding L and U, the next step of the algorithm is to calculate Y. Now we go in the calculation for Y. So there we have to use the step where L into Y is equals to B. So you have to define what is Y here. Y is a column vector containing as many elements as these are involved in your system of unknown equations, in system of linear equations. So here we have L, which is 2, 0, 0, 8, -7, 0, 4, 9, -27. Along with it, the column vector Y, 1, 2, and 3. And on the right side, we have B. And B is 12, 20, and 33. Okay. Now we transform back into the equations form. So from the first we get 2y1 is equals to 12. From here we get y1 is equals to 6. From the second we get 8y1, 7y2 is equals to 20 on forward substitution. Putting the value of y from here, we get 8 into 6 minus 7 into y2 is equals to 20. Now simplify will give you y2 is equals to 4. From the third we get from 4y1 plus 9y2 27y3 is equals to 33. Now substituting the values. y1, y2 already calculated. Put in the last equation gives you 4 into 6 plus 9 into 4, 27 y3 is equals to 33. From here we can separate y3, and y3 in this case is equals to plus 1. So we got all these three unknown for y. Therefore, y is 6, 4 and 1. After calculating y, the last step is to calculate u, and for this we have to once again take start from the algorithm equation which contains x, and that is ux is equals to y. Okay, and u we have, for here we can substitute it here, 1 by 2, 2, 0, 1 and 2, 0, 0 and 1. Along with we have the unknown x1, x2 and x3, and on the right side we have y. Y is 6, 4 and 1. Okay, now you have to write this matrix into the equations form. So we can write it x1 plus 1 by 2 times x2 and 2 times x3 is equals to 6. x2 plus 2x3 is equals to 4 and x3 is equals to 1. So from the last equation we got the first required unknown. This is your first solution for x3. We have to substitute back into this equation to obtain x2. So here x2 plus 2x3 is equals to 4 gives you x2 plus 2 times 1 is equals to 4. So we get x2 is equals to 2. And from the equation number 1 we get x1, 1 by 2, x2, 2x3 is equals to 6. X1 plus 1 by 2 into 2 plus 2 into 1 is equals to 6. On simplifying we'll be getting x1 is equals to 3. So ultimately we succeed in finding the solution of the system of linear equations. Therefore the solution is x which is equals to 3, 2 and 1. Okay, gentlemen. Now after finding the solution, you can verify the solution by substituting it back into the equations. If all these three equations satisfy with the solution, so then the solution is okay. Otherwise, you have to check where you have done mistake. And so this was the whole procedure for the LU-Decomposition method as well as the CROUT'S method. And hopefully you can understand all the things which I have described here. With this, thank you very much and Assalamu alaikum.